Okay, welcome back. We are now going to look at defining variables in Rust and how that compares with Python. So let's start with Python because we know exactly what to do there. We're going to say x equals 5. So what's going to happen is I'm going to create a variable named x. It's going to assign the value of 5 to it. Self-explanatory. What's happening here though is there's a lot of abstraction happening. We don't really know exactly the data type that x is because we could also say x plus equals 1.1. So, is it a integer here? Is it a float value here? It's hard to know what's going on exactly. It's very abstract in Python. So let's look at Rust. How does Rust handle this? So first, to create a variable x equals 5, we would say let, which is the keyword for creating a new variable in Rust, let x equals 5, semicolon. And when I let the IDE load that in, I get this nice little orange warning, and what that's telling me is that it's kind of a hey, FYI, you didn't specifically give this variable a data type. You didn't give it an integer or a floating point or anything data type. So just FYI, the compiler is going to treat this, it's going to infer that this should be an I32, and it's going to treat it like an I32, and it's going to hold it to all the rules that an I32 would be held to. So this is a nice display warning that I didn't set it, so it's going to infer that. Now, what this tells us is a couple things. First, Rust is a statically typed language, so the data types and sizes must be known at compile time, and any operations that you perform on the data must be compatible. So you can't put a integer into a floating point, a function as a floating that takes a floating point as an argument, for example. That will throw a compile time error. So we have to be very specific about our data types. When we're not specific, oftentimes the compiler can infer, but we're still held to the constraints of that inference. It's not like Python where it infers maybe an integer and then I can turn it into a floating point, and then maybe if without this, maybe I want to turn it into a character. So I might be like x, plus equals the letter A. So it's working with characters. So it gets kind of crazy with Python. It's very flexible. Oops, not int. X equals 5. Versus Rust, which is very, very specific. That's the big first difference. Now, what if we wanted to specifically tell Rust what the data type is? And by the way, this little warning here is just saying, hey, you didn't use this variable, don't forget it. So don't worry about that. Now, if I want to specifically give it a data type, let's say y equals 10 over here on the Python side. If I want to do that in Rust and be specific about it, I might say let y, now I'm going to do colon, and I'm going to put in my data type here. So my data types for integers could be an unsigned 8, 32, 16, 64, 128. Also have signed 8, 16, 32, 64, 128. There's also floating point values, so I could do f, f32, f64. So depending on how I want to define this, but let's say I want to do a unsigned 8-bit integer, it might be u8 of 10. So now I have a I32 with the value of 5 and a unsigned 8-bit integer with the value 10. So this is how variables are created in Rust. But there's actually one more trick to this. So what if, let's delete y, and we can, let's specifically call this an I32. So we know we have a integer value, 32-bit integer with the value 5. Now, what if we want to increment this by 1? So in Python, we would say x plus equals 1. Well, in Rust, we can use the plus equals increment or the addition operator as well. So we could say x plus equals 1, semicolon. But look what happened. We have an error. Let's look at what this error is. Cannot assign twice to immutable variable x. So what's happening here is x is immutable. And if I run this code and let it compile, cannot assign twice to immutable variable. And let's see what it says. Consider making this binding mutable. So the compiler in Rust, by the way, is extremely friendly. It almost tells you exactly what your error is. So what's happening here is in Rust, variables by default are immutable. Immutable means they cannot be changed. Versus Python, which if I create x as a integer, I can later just say x is a string. You know, I can assign values, add values, change values. By default, variables cannot be changed. So we have to specifically tell Rust that this variable reference is a mutable reference. We want to be able to change the data that's stored in that memory. And to do that, we use the mut, M-U-T keyword. So what I'm saying now is let x be a mutable reference to a value that is containing I32 data and assign the value 5 to that. And now I can say x, which points to this, this data. So x points to a 32-bit integer, but x is a mutable reference. So this reference x allows me to change the data that's stored in that memory. So take that data and increment it by 1. And then I can now print, and I can put x in here. And what's really nice about Rust with the string is they are almost identical to Python's formatted string. So if I do f, which is a formatted string with the brackets just like this, I can pretty much do exactly the same thing here. So I have 5. Oops, I didn't increment it. So we'll do x plus equals 1. That will increment my Python code very, very simple. And now I can increment my Rust code. So I have a mutable reference to an I32, 5, increment it by 1, and print it. So if you look at this code side by side, you can see that Rust and Python in many cases look very similar side by side, but Rust deals with a lot more of the low-level details and explicit details, while Python tends to abstract that information.